I'm ready. Oh, sorry.
Okay.
I'm still sharing. I'm ready.
Okay, so one of the questions on the practice was 7 times, and then in parentheses, 3 times 1. And I kept trying to write it as like 7 times 3 in parentheses, and then times 1 is the actual answer. But
So this is the associative rule. That's correct.
The actual answer, but I kept trying to write it.
But are they asking us to use the associative or the commutative?
Associative.
Okay, so this is correct. 7 times 3 times 1 is the same with 7 times 3 and times 1. And that
Okay.
they are considering it incorrect?
No, that was correct.
Yes.
I kept trying to do like 7 times 1 in parentheses and then put the 3 on the outside.
This is also correct. This is also correct.
Okay, it would tell me that was wrong.
Yes, but this is also correct.
Okay.
The reason, so they are the same. The reason this is considered incorrect is because they want you to use the order from left to right.
Okay, that makes sense.
But you are correct. I even taught you that. I even said it doesn't matter. But if they wanted to use the associative property of multiplication, they really mean, of course you can do whatever, but they really mean to work from left to right.
Okay, that makes sense.
Because actually the rule is this: AB times C equals ABC. So they really want you to use this, although this is absolutely correct and it's the same thing. How do you get here from here? First, you will use the commutative law of multiplication to get to what you said. So you introduce another step, which is absolutely fine. So basically, you said this: 7, 1 times 3. So you use the commutative law of multiplication, and then you used the associative law. Okay, so you introduced an intermediate step, which is absolutely correct, and this is absolutely correct, and this is absolutely correct. But they didn't want you to use the commutative law as well.
If that was a test, would you have given credit for that?
Yes, yes.
Okay.
Yes. I mean, this is really too strict. I'm okay with all of them. But again, just remember, this is the rule. So this is the rule, and as you see, the parentheses are moved one step at a time, and we're not switching inside. We're not using the commutative law inside to get to what you came up with, but they're all correct. You just use the commutative and the associative, not just the associative. Is that better, Sarah? Okay. So you did more than like an overachiever that you are. Okay, good. Anything else? Other questions?
I did have one question.
Yes, I'm ready.
To expand on what Sarah was saying, the absolute value, can you rearrange with the absolute value?
No, no, because the absolute value is not a grouping symbol.
Okay.
But inside the absolute value, if you want to say 7 times 1, yes, this is the same with 1 times 7 in absolute value.
Gotcha. Okay.
But you cannot jump. You cannot rearrange the grouping with the symbol of the absolute value because it's not a grouping symbol.
Okay.
Very good question. I always tell my students, your questions make me a better professor because there are things that I did not think to explain. Good. Anything else that you worked on? Anything else you need help with? Anybody? Don't forget to unmute yourselves if you want to say something because I can't hear you. Okay, so can we start then the next steps? Yes? Give me a sign, any sign. Okay. So I would like to talk about exponential rules. Exponential rules. and how to evaluate exponential expressions. First of all, what is an exponential expression? An exponential expression has a base and it has an exponent. This is what it's called, an exponential expression, or you can also call it the exponential notation. Okay, let me give you a few examples so you understand what this notation means. So for example, I need that to sit tight. So for example, if I have 2 times 2 times 2, I copy the base. It's the same. And I put a power based on the number of 2's that I see, 1, 2, 3. And I just created an exponential notation. 2 is the base, and 3 is the power. How many times 2 appears as a factor? This cannot be confused with 2 plus 2 plus 2. This is not 2 to the third. So they all have to be factors. If they're not factors, you cannot write an exponential notation. This is 2 plus 2 plus 2, which is 6. It has nothing to do with this exponential notation. Okay, my next step is, of course, this exponential notation comes with tons of rules. Tons of rules. Okay, here's one. A to power n. So my n has 2 bubbles, times a to power m. My m has 3 bubbles. What is this rule? So make a note that both bases are the same. Otherwise, I cannot use this property. So this must be the same with this. And they are. So I copy the base and add the exponents. N plus m. A simple example, 3 to the second times 3 to the fourth. What will that be? And remember, we copy the base. Nothing happens to the base. We don't touch it, we don't add it, we don't multiply it, we don't anything. So, can anyone give us the answer here?
3 to the 6.
That's it. So this is the power rule, the product rule. So when we have a product, when we multiply, we copy the base and add the exponents. What I want you to understand moving forward is that this is, again, dynamic. What does that mean? Well, remember what I said about factoring and the distributive law? Let me go back here for a second, just quickly. It goes this way and also goes this way. This is not fixed, right? From here I can get here, and from here I can get here. The same thing I want you to understand with this about this these exponential rules. Back and forth. So copy the base, add the exponents, and if the exponent is a sum, I can go back and write same base to n plus n on the first one. It doesn't matter, the order is not important because we know that multiplication is commutative. So a to n times a to m. So this goes both ways. Here's the second rule. A to the nth power over a to the mth power. I copy the base. In this case, we subtract the exponents. Always in this order. From the exponent of the numerator, we subtract the exponent of the denominator. Carved in stone, no matter what it is. So for example, I can have 2 over 2 to the third. Well, there is an imaginary 1, of course. If I say 2, I mean 2 to the first power. So I have to copy the base and subtract the exponents. Always from the exponent of the numerator, I subtract the exponent of the denominator. And now it happens that 1 minus 3 is, anybody?
-2.
-2. Well, we have a rule for this as well. What is it? When I have a base raised to a negative exponent, this does not mean a negative number. It's a fraction. And you can say a fraction? Yes. It's a notation that represents this. Notice that this is positive now. So 2 to -2 is 1 over 2 squared. And notice that this is not a negative number. Never assume that if the exponent is negative, oh, I know I'm going to get a negative number. No, no, no. If there is a negative in front, yeah, it's possible. But not because the power is negative. No. So then this becomes 1 over 4. Okay, let's recap for a second. Of course, back and forth. You can write this as this. You can write 2 to -2 as this, and you can write 1 over 4 as this. They are the same. So let's look at these 3 rules. We have more rules in a minute. When we multiply 2 exponential notation with the same base and different exponents, they can be the same, true. We copy the base and we add the exponents. When we divide 2 exponential notations with the same base, we don't ever touch the base. We copy the base and we subtract. From the exponent of the numerator, we subtract the exponent of the denominator. If it happens to get a base to a negative exponent, most of the time we are required to write it as a fraction. What fraction? 1 over 2 to the positive exponent, and then change it in this case into 1 over 4. So we looked at 3 rules so far. Okay, let's move on. There is more. Once we invented a notation, of course, it comes with all sorts of properties now. Okay. Here's the next one. A to the power n, everything to the mth power. Wow. Here, of course, we copy the base, but this time we are going to multiply the exponents. Is that okay? Good. An example. Let's say 3 squared, everything to the 4th. I copy the base. What is the power? And of course, back and forth. If I see a power like this, I can write like this or like this. How come? Because I already learned that multiplication is commutative. I can write a to the nth or a to the mth power raised to the n. Back and forth. Can anyone help with this example?
It's
8.
Very good. Copy the base, multiply the exponents. Good. One more for now, and then we'll talk about evaluating those. Okay. A raised to 0. The answer will always be 1, but there is a catch. If A is not 0. Remember last time I said 0 over 0, you have to wait till calculus. I'm going to say now that 0 raised to 0, you have to wait till calculus. So the base cannot be 0. If the base is not 0, the answer is always 1. For example, 3 to 0 is 1. A times B times C, everything to 0 is 1. Okay. I would like to open, I have it here open in the background, it should be, yeah. Good. So I'm gonna open, I'm sorry about that. So we'll go to share. Okay, so I just want to draw your attention to this problem. So this is in section 1.3, exponents. We didn't get to order of operations. We did a little bit last time, but I will explain the order of operations and we'll have plenty of examples. I just wanted to say that this is absolutely terrible and unacceptable. If you remember, we talked about this situation and I said, this is unacceptable. There must be parentheses separating two operating symbols. So if I have minus and product, minus and plus, plus and product, you name it, in any order, whatever you want, these cannot crash like this, or minus, minus. There is no such thing. So the way they wrote this sequence is unacceptable. So this should have been written in the following way. Let me say this. So there is no separation between the multiplication symbol. The first one is okay, the first -8. But then product and minus is not acceptable. Which one is it? Am I multiplying by -1? Am I multiplying by -8? What is going on? So this is completely unacceptable. The first -8, as I said, it's okay. But the next ones are not okay. This is the correct presentation. Please remember, two operating symbols cannot sit one next to the other. This is not acceptable. Okay, the first one is okay because there is nothing else in front. With parentheses, without parentheses, it's fine. Now, depending on what they meant. Okay, so remember what we just did. We know the sign, but let's assume that they meant this for now. How do I write something like this using exponents or an exponential notation? How would you write it? What is the base?
-8 to the 4th.
Yes, -8 to the 4th power. Now you have to be careful because remember there are 4 negatives. What should the sign of the outcome be?
Be positive.
Indeed, it has to be positive. Positive here, positive here. Here's another way. Remember what I taught you, that negative sign is always like a -1? So you can take -1 to the 4th power and 8 to the 4th power. I haven't presented that rule. Let me put it. Let me put it here and I'll come back. So here's another rule. A times B to the nth power is A to the nth times B to the nth. And yes, some students may say, oh, you're distributing. No, no, this is not the distributive law. This is the distributive law, and it requires multiplication with addition or multiplication with subtraction. This is the distributive law. I'm not distributing the power to the 2 factors. No. I'm raising a to this power multiplied by b raised to this power. Please understand that this is not a plus b to the nth power. This will be an absolute terrible mistake to write a to the nth plus b to the nth. And if I have minus, the same thing, a terrible error. This will be a terrible error. Never. Why? Because these are factors. Yes, Silas, you wanted to say something?
Yeah, if it's not referred to as distributive law, what would it be referred to as?
A power rule.
Power rule.
Yep.
technically.
So these are factors. These are terms. They're factors because they're multiplied. They're terms because they're added or subtracted. The rule for factors is this, very simple. The rule for two terms is way more complicated than this. So
So it's
please,
only for multiplication.
I'm sorry?
So it's only when you're multiplying.
Exactly.
Okay.
The power rule is applied for factors. Yes. So please remember, this will be a terrible mistake. Actually, this is the only class in which I do not start with the formula a plus b squared, because we haven't gotten there. But believe me, it's a pain. It's really painful to see even my students in calculus say or write a squared plus b squared. And this is very painful to see.
I suppose you would have to add the a plus b and then squared.
Exactly, by the order of operations. But if you don't have them, because the formula does not give us a and b, it's a special product. You do not have to worry about this right now. This is a squared plus twice ab plus b squared. If the power is 2, there will be 3 terms. If the power is 15, there will be 16 terms. It's huge. So please understand factors versus terms. Okay, perfect. What was I doing here? So therefore, you can say -1 to the 4th power times 8 to the 4th power. You don't have to, but this is another rule that you can apply. You can just say it's a negative number 4 times. The answer must be positive. How do I use a calculator on this? Okay, let me share my screen and then go to here. Okay, so 8, we put a caret right here. This is for the power. And when we put 4, we get the answer.